Hello Midwest team, it's Rob here at Clover. I thought I'd put a video together for you. Visual's always good. We tried to make a run with the blanks we currently have in stock, as you know, last week. We're still in the press. We're going to run again tomorrow. We had some lube issues on the press, but anyway, we ran approximately 800 pieces. And I just wanted to make this video to give you an idea of the issues we're coming across while we're running these blanks. As you can see here on the table, I've lined up a whole bunch of blanks and some parts, and I'll go through them. You can see as I pan down here, I've lined up the end with the pointed triangular tab all lined up, and I've lined up all the ends of the blanks. And as I scroll down here, you can see the variance we're having in the length of the blanks. You can see that one down on the end. I'll scroll this way also. You can see while I scroll down here, also there you can see there was a couple of these scrap pieces that were shoved in between the blank, and it was sticking out of the blank when we took it out of the bin. And as I scroll down here, you can see the variance in the length of the blank. I know you guys are just dialing in your new line, but I just wanted to make you aware of this because this really screws up our run out rate and our efficiencies if this keeps coming in this way. If we do receive a blank that is a little too long or too short, the part may not be to spec and we might not catch it. Also, this one here, you can see it's double on there. This blank is double. It's got 4 layers and two fibers in there. Here's another lineup, same thing. Just going to pause it for a second. Also, you see these tabs here. If our tabs are bent like this when we receive them, they screw up our conveyor, and we also can't load it into the feeder. So that'll be a scrap blank for us. We'd have to rework those blanks and set them aside. But again, this guy's loading these blanks by hand into the feeder, so the press is going to stop every time. Also here you can see these scratches on here. I'm not sure how that happened, but that's the way we received it. Also, if the corners of the blank aren't straight, it won't feed, our feeder won't feed it into the press. Also this one here, if they're bent and not flat, it won't feed. Here you can see the mismatch. I think you got a sample of this already. And down here, here's another blank. You can see that's way mismatched. I mean, that one's really bad. But this one here, we can actually load this in the feeder if the operator doesn't catch it, but it won't fit in the nest if it's the right length. It's offset. Also, the fiber might be in the wrong spot, which I'll get to in a second. I'm going to pause it again. So here I wanted to bring your attention. These are the parts that we had first offs at Verbom and our first hits at Clover, but it didn't have the emboss in the blank. It was just 2 flat outer layers. And as you can see, the wrinkling is very minimal on these ones. When you go to parts with the emboss for the fiber, you can see how bad it's wrinkling, and I've shown you guys this already, but I just wanted to bring it to your attention again. Also, on the emboss, I wanted to bring your attention that when I try to line up the fiber inside the emboss, if I line up this end here, with a mil or so clearance, when you go to the other end, you have this much. It seems the emboss isn't the same shape as the fiber, which gives us a little bit of a challenge here, because this end right here, when we pierce that hole, that emboss here, that's the shape of the emboss, is too close to the pierced hole, and it causes some burring issues. We had to stop several times and resharpen the punch. We actually relocated the blank in the press so it would move it away from there a little bit, like this one. You can see that there. We relocated the blank in the first stage to improve it, but this emboss, and then it gets too close down here. So you try to move it around and it screws us up. Here, I think the emboss is too close to here, and it looks like the fiber actually goes right through the center of the hole. So I cut it out here. I don't know if you can see this on this video, but we're actually piercing through the fiber. So here I'm going to lay the blank onto here. So it kind of sits in this general area. That's what we're looking at here. So I'm not sure if the development of the shape of the fiber is correct, but anyway, that's something to look into. But the request I have is, what's important for us in order to be successful while we're running is that this emboss is in the right location of the blank itself. I'm not sure how you can prove out that it is. You know, if we could take dimensions from here and check that in your process to see if it's consistent. Also, on the blank size itself, I'm assuming that this is your strip width, the 15 and 1/4. The 1/16 is probably your feed length. We're looking for a 1 millimeter max, plus or minus 1 millimeter max variance. We'd like less than that, but I'm not sure if you can accommodate that. But if it was plus or minus 0.5 millimeter, that would be even better. But you know, at the maximum, it'd have to be 1 millimeter. Once we get more than that, then it's going to affect us when we're trying to form it in the first form, and then the shape is going to be too close to the hole. I'm going to pause it again for a second. I think Sal was communicating with you guys regarding the feeler to check the profile call out on the drawing, which is 8 millimeters. That's the general block, but then there's one up here that's 9 millimeters for those areas, I guess. But regardless, if we go to the fixture over here, you'll see that we have a feeler that's 4 to 8, which is a 4 millimeter tolerance. So this feeler, we require a new feeler, one with the go at 2 millimeter and the no go at 10 millimeter. So I don't know if you guys can send us a new feeler. Again, go has to be 2 and no go has to be 10 as per the drawing. So on the fixture, on the datums, we have a 6 mil offset, so 4 millimeters, so that'd be 2 and 10 millimeter go no go gauge. If you could let us know if we could get one of those, please. So gents, in closing, I just need to say that I'm sure the process for your packet line is going to improve, but if we receive blanks that are of a quality similar to this, or if 1 or 2 or 3 get lost or missed in your process and we process them, we really have no way of making sure of 100% conformity when we ship Bentler parts, which is a big concern of ours. Like if there were, out of a bin of blanks that we receive from you, we receive one that is of that size or that we're looking at there, or God forbid we receive one of those double blanks and the operator puts it in the machine, there might be a failure in the die. And also with these smaller blanks or a larger blank, the quality of the part will not be as per what we are making normally. So we're concerned on how to ensure that Bentler gets 100% good product. Right now, the way it stands, we can't guarantee anything. So, I mean, we will be GP12ing everything for the first couple lots, but anyway, hopefully we can discuss it with you on the next shipment of blanks that we receive and see what kind of quality we get. Thanks for listening.
And
So I'm not sure of what you guys are going to do, but I think it'd be a good idea for your guys to 100% certify the size of the blanks and everything's kosher with those blanks coming in. So then we could get a good run-out rate done for Bouchan, and everybody's happy. Thanks for listening.